Welcome back to Disruptors Unleashed, where we explore bold, disruptive ideas and chat with the trailblazers who are redefining industries as we know them. Previously, we took an exciting look at how virtual twins can decarbonize rail freight with 9-year-old infrastructure Bernardo and Muthu Sivanandam from Dassault Systems. Today, we continue with our exciting new mini-series featuring our very own infrastructures. The Dassault Systems infrastructures are the small but mighty engineers, builders, and designers of tomorrow who are asking the big questions like how can our infrastructure and cities change to tackle the challenges of today and tomorrow? Joining me today is Virgil, our 10-year-old infrastructor. He's taking the mic to chat with Alex Dassault, one of our leading experts in the cities and public services industry, who is uniquely placed to talk about a huge issue facing cities today: how to adapt our infrastructure in light of our changing climate. Take it away, Virgil.
Hi, my name's Virgil. What's your name?
Hello Virgil, my name is Alex Dassault. I am business consultant for Cities and Public Services team in Dassault Systems, and I am also geospatial expert and remote sensing scientist.
So, I've been seeing stories about flooding in the news more and more, and I've even started hearing about it affecting some of my friends. What causes these floods, and what can we do about them?
Firstly, when we talk about flooding, it's not just one size fits all, there are several types of flooding. We have, for an example, the riverine flooding. It happens when the river spill over heavy rain or snow melt episodes, so it's pretty common in large catchments. Then we have the flash flooding, which is super fast and dangerous, like often hitting within minutes of intense rainfall, especially into urban areas or steep areas where water can soak into the ground. Then we have the coastal flooding, is another big one, really common, and usually driven by storm or high tides or even like tsunamis, and it's becoming more of a concern with the rising sea levels due the climate change. The pluvial flooding is one of the most normal ones. That means surface water flooding, rain that builds up into the streets and low spots when drain can't keep up. We have also the groundwater flooding. It's the less known type of flooding because it's really slow and sneaky, and it's caused by water tables rising after long wet periods. And the most important one is the flooding from dam failures because it's human caused and it's sudden, it's powerful and often devastating. So I would say that understanding these different types of flooding can help us to better prepare, to plan, and to manage flood risks across different landscapes. In addition to understand like the different types of flooding, I think it's important to understand the different dimensions of the impact because flooding isn't just about water covering land, it comes with some serious human and economical problems.
Yes, this is what we're worried about. So, how bad can it be?
So on the human side, floods can displace like entire communities, can cut off like critical services like power, water, transport, schools, hospitals, and tragically can lead to injury or loss of lives. So especially like in flash floods, because people try to drive through flood waters, they don't understand like the gravity of the situation and they try anyway, and it could be like really dangerous for them. And not only like beyond the immediate danger, there's also the long tail of mental health impacts because people can suffer from trauma, from stress. So it can affect like individuals, but entire communities as well. Talking about the economy, the hit is massive. So we have damage to homes, to business, to roads, to public infrastructure. It can really rack up billions in repairing and recovering costs. For an example, like if we talk about insurance, the price of insurance can skyrocket or disappear completely in high-risk areas. And for local economies, flood can wipe out agricultural production, like disrupt supply chains, and force business to close.
What are we talking about in absolute costs?
One really important information, because I was reading the official reports from the UN Office for Disaster Risk Reduction, the UNDRR, and I found that from 2000 to 2019, flooding alone made up about more than 600 billion US dollars in losses worldwide. So it's a lot of money. So when we talk about flood risk management, we are not just trying to protect buildings. Actually, we are talking about safeguarding lives, protecting communities, and also like entire economies.
Wow, it's really serious. Couldn't tech help? I mean, if my dad's phone can predict the weather, couldn't we better model and anticipate flooding?
Totally, like that's the power of the simulation that we have. Of course, it's not easy to make weather and climate simulations, because actually we are going to use a lot of information. We are not just guessing like where the water might go. Actually, we are using a bunch of real-world variables to make it precise and useful. So what type of data we are going to use in our models? We are going to use rainfall data, like how much, how fast, where it's falling. We are going to use geographical information like the terrain models, informations like elevation and the slopes. We are going to use the land use as well, because water is going to behave differently on concrete than it does on grass or soil. We also bring details about drainage systems like sewer capacity, the river levels, tides if we are close to the coast, and even weather forecasts. So you can imagine, like, we have different types of information that we are going to feed into the virtual twin to create like a super detailed model of the flooding phenomena. And this model is going to help us to spot like the weak points, to understand the different scenarios of mitigation, and to plan the best way to keep the city safe for the people who live in it.
Phew, that's a relief. But how?
So I believe with this tool, we are no longer stuck just reacting to the flood after the damage is done. With the tools that we have, like the virtual twin, we can actually anticipate where and when the flooding is likely to happen. So that means we are going to plan ahead. So we can reinforce flood defenses, we can reroute infrastructure, and we can create like smart emergency plans. So it's about spotting the risk before they turn into disasters. So yeah, I think with the tech that we got today, geospatial information, remote sensing, or even like the virtual twin, there's really no excuse not to be ahead of the game. I believe that flooding may always be a threat, but it doesn't have to be a surprise.
I agree. Could you tell me more about what your team is doing to achieve this?
Yes, of course, Virgil. So I've been working with the Cities and Public Services team at Dassault Systems, and actually we have something that we call the Urban Virtual Twin as a Service.
The Urban Virtual Twin as a Service?
Basically, is a tool that is going to help the local governments and the emergency entities to better understand this type of phenomena. What we are going to propose for these people, it's like we are going to collect the urban and environmental data, we are going to run the simulations, we are going to make analysis of the results, we are going to generate reports, and we are going to make a citizen communication strategy. So basically, we are going to use the data from the collection until the communication with citizens. I think this is really important because we are going to use scientific insights to make a useful information for the population.
This sounds like a lot of information to manage. How can it be collected and analyzed?
So today we have what we call the 3D experience platform. So basically, it's a single source of truth. So you can imagine like all data, all processes, all information, all people working together. So you have different stakeholders. You can imagine like the urban planners, the environmental agencies, you have the civil associations, and they are going to collaborate inside the same platform. They are going to have access to the same information, and then they can have the best decision for the city, like a collaborative decision for the city. And it's important to say, like, because cities are really complex. Like you can imagine different layers on top of each other. Like it's a system of systems. So you can imagine roads, network, we have the buildings, we have the water system, we have the energy system, we have the people, so you can name it. So when something like the flooding happens, it's going to throw out like the whole balance of the city. So that's the importance to understand how flooding happens and how it moves through a city, like not just the spatial dynamics of the flooding, but also the temporal dynamics of the flooding.
So where do virtual twins come in?
So that's the reason I say that the virtual twin is really an important tool for us, because it's smart, is interactive, is a digital version of the city where we can put like all types of data. So you can imagine sensors, IoT data, citizen information, we can put city departments information, even private companies can collaborate as well. So it actually let people see what's going on, and it doesn't stop there, because you can simulate all this information. So what happens if this river overflow, or what will happen if this neighborhood is exposed to a heavy rain episode? So that's the real magic. From urban planners to emergency services to regular citizens, everyone can look at the same virtual model of the city and collaborate and plan ahead and make better decisions.
So what does this mean for public authorities and the people who actually have to deal with floods?
So I would say that this type of technology, instead of reacting when things go wrong, as we can have a step ahead and we can anticipate potential risks. So it's about being prepared, efficient, and make life better for the people who live in these places. Using a virtual twin isn't just about watching what is happening right now, but is also to understand the future. So if we know the areas are likely to be flooded, we can start putting real plans in place. So that could mean better flood defenses, or setting up smarter evacuation plans and emergency routes as well. So instead of scrambling when the water is already rising, I think we got a solid game plan. So it's all about being proactive instead of reactive. When we talk about flooding simulation, it doesn't just help city planners and urban management. It actually helps emergency services too. So when we can simulate a flooding scenario, so we can start figuring out like exactly where the biggest impact it will be and when it might happen. So who needs to be there? So that's where dynamic workforce planning tools comes in. So it's like a smart scheduling for emergency teams. So basically we're going to match the right people with the right skills to the right place at the right time. And it's not static, it's dynamic. So if something unexpected happens, the system can adapt on the fly. So instead of chaos, we've got a coordinated response. In short, we are going to use the simulations to make a better management of the workforce for the emergency services team. So I believe it's a fast, smart, and dynamic decision for the city.
Sounds great. Thank you so much for speaking with us today and telling us all about how technology can help us tackle flooding.
Thank you, Virgil. It was a pleasure to talk to you, and looking forward to see what you and the infrastructures are going to do next.
Back to you, Yanni.
Thank you for your time, Virgil and Alex. Want to hear more? Tune in to Disruptors Unleashed to listen to other infrastructures on the biggest challenges impacting our infrastructure and cities. Till next time. Disruptors Unleashed is produced by Dassault Systèmes. For more episodes, follow us on Apple Podcasts, Spotify, Deezer, or your nearest audio streaming platform. To learn more about Dassault Systems, visit us at 3ds.com.